let's start with the question 4. So a project with a lifespan of 4 years has the following stream of benefits and then cost. So we have the time from the basic year, the base year to the fourth year, and then the benefits. So the year that the thing was made, there was no benefit. And then the projects only incurred an initial cost of 100. So we are to determine the internal rate of returns. For the IRR, we have two ways of doing it. What we are trying to look for is we are looking for the interest rates that will equate the NPV to 0. So we normally find NPV assuming a particular interest rate, then we solve for the interest rate. We equate NPV to 0, then we solve for the interest rate. But if you have more than 2 years, you will be getting out to the power 4. This one, we have 4 years. So if you use the normal way, you'll be getting out to the power 4, and solving that is going to be an issue. So we just use the try and error. Then there's a formula that was provided. Then we just use that. So what we try to do is that we try to find use two interest rates, arbitrary interest rates, and then one for the NPV to be negative and then one to be positive. When we get it like that, then we'll use those interest rates to get the R star or the internal rate of return. So these are the information that we have on benefit and then cost. So let's use the try and error, and then we'll see what R star we can get. All right, so you just have to choose any R. This thing, it can be very time consuming and confusing. Okay, I think I used about 4 interest rates before I was able to use this 70%. And then what the main thing is that you have to use one interest rate, use it to find the NPV. One should be positive, one should be negative, which means that in between the two, the NPV can be equal to 0. That is the IRR. We are looking for the interest rate that will equate NPV to 0. So if you are able to guess an interest rate and then you get the NPV to be exactly 0, then that's all you are done. But it's very hard getting that. So you just have to be doing try and error. You pick any interest rate, you put it inside, then you see the value of the NPV. Then you pick another one, you put it inside. One should be positive, one should be negative. And then the difference between the two shouldn't be too wide. Okay, it shouldn't be too wide. When it's too wide, it makes the R that you will find very big. Okay, so if we assume the interest rate or the discount rate is equal to 70%, then first you have to find the gross present value. Okay, the gross present value. So you just discount the benefit for each year. So for the base year, the year 0, there was no benefit. So we just ignore that one. Then for the first year, T is equal to 1. We have the benefit was 50. So 50 over 1.7, just add 0.7 to 1. The formula is the benefit divided by 1 to plus R to the power T. Okay. So if T is equal to 1, here R is equal to 0.7. So the denominator will be 1.7. So if T is equal to 1, then we have 50 over 1.7 to the power 1. Then the second year, the benefit was 100. So 100 over 1.7, the T is 2, so 7 squared. Then the third year, the benefit was 120. So 120 over 1.7 cubed. Then for the fourth year was 150. So 150 over 1.7 to the power 4. So we are getting 106 point something. That is the gross gross present value. Okay. So if you want to find your NPV, the net present value, you just have to subtract the initial cost. Okay. We don't discount the initial cost because if your discount is in the present time, even if you want to discount it, it will be 100 divided by 1.7 to the power 0. and any number to the power 0 is equal to 1 because t is equal to 0. There are cases where you get a benefit in the starting year. That one too, we don't discount it. It will just be the value there. So if you want to find the NPV is the gross present value minus the initial cost. So subtract 100 from it, and then this is what you are getting for the NPV when R is equal to 70. Okay, so you see that this one we've gotten a positive number. So then we'll pick another one. If we pick R is equal to 70, you are not restricted to pick any particular interest rate. It's just your own thing. Okay. So if we pick R to be 75%, then we find the gross present value again using 0.75 as the interest rate. So you do that, you discount the benefits for all the years, and then hopefully we are getting 99.6085. So this is the gross present value. You find the net. The net present value will be the gross present value for the benefit minus the initial cost. So this one we are getting negative. Okay, so now we've been able to get one positive and then one negative. So from here we have to use the formula, and I'm sure you all have that. This RL is the lower interest rate that you paid. That is 0.7. And then the NPVL is the net present value for the lower interest rate. So here, this is what we got. And then RH is the high interest rate, the higher one, the higher one that we paid for. This one was 0.75. And then this was the NPV. Okay. So your R star that you find is equal to RL, the lower interest rate. Then we add into brackets the NPV for the lower interest rate divided by NPV for the lower interest rate minus the NPV for the higher interest rate times the NPV, the higher interest rate minus the lower interest rate. I forgot to write the formula, okay, but I hope you guys have it. So you just have to insert the value. So 0.7 is RL, the lower interest rate. This is the NPV for the lower interest rate. This is NPV for the higher interest rate. This is the higher interest rate minus the lower interest rate. Okay. So you just need to simplify this. And I got 0.7471. 0.7471. So this is going to be the IRR, the internal rate of return. Okay, the internal rate of return. So you just have to choose any. If you choose 10% and then 20%, you realize both answers, both NPVs will be greater than 0. So you have to change them. Okay. So if you don't take your time, you'll be changing and changing and changing, and there's this stop it. So you just have to be very quick about this. Just try and get. Just know that the higher the interest rate or the discount rate, the lower the present value. Okay, so if you pick 10 and you realize that the NPV is very large, then it means you need a higher interest rate. Okay, 10 might be, assuming you use 10, I think this one, if you use 10, the NPV is around 150 something. You realize it's too huge. It's nowhere near 0. So you need a bigger interest rate. If you use 22, I think it was almost over 100. So you just try to use a bigger one just to save time, because whichever interest rate that you use, you are coming to do all this. Assuming you have 6 years, you have to be punching all the distance on the calculus, and it can be time consuming. So just know that the bigger the interest rate, the lower the NPV. So if you pick 10 or 20 and you realize the NPV is too high, you just have to pick a higher one, just to get a smaller NPV. All right, then let's look at the B part of the question. Now they are saying that assuming the market interest rate is, or the discount rate is 5%, we are to comment on the viability of the project. Should the project be, should we actually undertake the project or we shouldn't? Okay, all that you have to do is you just need to get the decision rule. Okay, so the decision rule is that if the IRR that you get, the R star that you get, is greater than the market discount rate, then yes, the project is viable. We accept the project. And here we had 74 point something percent, and it's greater than 5%. So we accept the project. So that is how we use the IRR. But if you are lucky and you just get 2 years, you can just use the formula. Okay, so that one, your MPV will just be equal to the benefit for the first year divided by 1 plus R. Then the benefit for the second year over 1 plus R all squared, okay, minus the initial cost of that is equal to 0. Then you solve for R. Here you get a quadratic equation in terms of R. So you can just use the almighty formula and you get the exact IRR without going through the trial and error. But if the years are more than 2, if you have cube, it's going to take time before you get the root of R. So that's that for the IRR. I think the last part was some of the limitations of the IRR. So later you can just read through this one. Yes. All right. This one too was another IRR. Okay. Let's see. The question 6. So given the initial investment in a factory processing equipment as 500,000 Ghana cedis, let the opportunity cost of capital for the industry be 10% per annum. Assuming that the equipment is capable of generating an after-tax profit of 115,000 Ghana cedis for the first 4 years, and then 65,000 for the second, for the last 2 years. So we are to find the net present value and then determine the internal rate of return. So here, my understanding is that the project lasted for 6 years. Okay, it lasted for 6 years, and for the first 4 years, each year they were getting a profit of what? 115,000, and then for the 5th and 6th year, they were getting 65,000. And then the discount rate here is what? It's 10,000. And then C0, the initial cost is 500,000. So we have to find the net present value. Then after that, we find the IRR. Okay. So let's look at that. Okay, so the C0 is the 500,000. And then we need to find the gross present value for the benefits. The discount rate is 10%. So the denominator will be 1.1. So for the first year, we have 115,000 over 1.5. Then the second year, 115,000 over 1.1 squared. You do it up to the 4th year. Then the 5th year, the profit was 65,000. So 65,000 over 1.1 to the power 5. Then the 6th year 2 was 65,000. So 65,000 over 1.1 to the power 6. So this is going to be the gross for the benefit. So if you want to, you just have to simplify this, okay, to get this value here. Please, of course, you have to verify it. Then if you want to find the MPV, is the gross present value for the benefits minus the initial cost. So doing this, we have minus 58,440.7822. So this is the value of MPV. So assuming we were to check the viability of this project, because MPV is negative, we would have rejected the project. But this question, they didn't ask for that. They just wanted the MPV. Okay, but in case, if you remember the decision rule for a single project using MPV, you have to find the MPV. If it's greater than 0, you accept the project. If it's less than 0, you reject it. So in this case, we would have rejected it, but that is not what you are looking for. So you just state your the MPV. Okay. Then the second part of the question was to find the IRR. So this is what we got from using 10%. So let's just use that one just to save time. So you are not bounded to use any particular interest rate. So just to save your own time, just pick what you've already done from the I part. So the high one, 10%, and then we had an MPV to be 441,585.2178. Then let's use 5% too. So the low interest rate or the lower interest rate to be 5%. So the discounting factor is going to be 1.05. Okay, so first you find the gross present value for the benefit. You go through the same process, but here we are using 5%. Okay, we are using 5% here. So do it for 5% as we did for 10%. We are getting the gross to be 507,217.5096. Okay, this is the gross. Then we need to find the MPV. Okay, we need to find the MPV. So here we are getting the gross, which is 507,217.5096 minus the initial cost, which is 500,000. So that here we are getting a positive number, 7217.5096. Okay, 5096. So this one, the MPV for the high one is supposed to be minus 58. Okay, I think I made a mistake here. So it's minus 58. I wrote the gross. So please, when you are doing it, check it well. Okay, minus 58 is supposed to be MPV for the high one. And then the MPV for the low one is 7217.5096. Okay. So when you come to the formula, remember this side was RL. So the lower interest rate, that was 5%. So 0.05. And then in the bracket, the numerator is the MPV for the lower interest rate. That's what we got, 7217.5096 divided by the MPV for the lower interest rate minus the MPV for the bigger interest rate, which is minus 58414.7822 times the bigger interest rate minus the lower. Here, the bigger one is 10%, the lower is 5%. So 0.1 minus 0.05. So you just need to do this, okay? Just simplify this, and hopefully we are getting 0.0555. You see that this one we've been able to get a very low IRR. So this one too, assuming the from the question, I think the discount rate was 10%, right? It was 10%. So here you see that the internal rate of return is 5.55%. And it's lower than the 10% that was given in the question. So we would have rejected this particular project. Using 10% for MPV2, we had minus 58,414.7822. So MPV would have rejected the project, and then the IRR2 is rejecting the project. Are we together? Are we together?
Yes,
Yes,
sir.
please.
All right. Now, just assuming we're to use benefit cost ratio, okay, B over C. Now, here, the MPV here, the total benefit that we're getting throughout the span of this particular project was 441,585.2178. If we divide this by the cost of 500,000, you see that the answer will be less than 1. And for the benefit cost ratio to if the answer is less than 1, we reject the project. Okay, the benefit should be more than the cost before we can accept it. So if we had to use benefit cost ratio to, we would have rejected this. Okay, we would have rejected this. So that is that in case you are asked to use the B over C as well. All right. Let's look at the B part of the question. We're given these projects, project X, Y, and then Z. Okay, and we are to use the MPV decision rule to evaluate the project. So which one are we going for? If the interest rate is, or the discount rate is 5%, and then if it's 10%, are we going for X? Are we going for Y? Are we going for Z? Okay. So which one should we go for and why? So we have to find the MPV for all the projects using I, 5%. Then we make our decision there. Then we go to II, 10%. Then there to make our decision. Okay. So let's look at the first one when the interest rate is equal to 5%. Okay, so R is equal to 5%. Let's take the first project, project X. Let's find the MPV. Here, we've just been given the stream of benefit and then cost. We don't actually know if they've already subtracted their cost and all that, but these are just the values that we were given. So those are the ones that we just have to discount. Okay. We can take this minus 175 as an initial cost. And remember, this is for the base year. Okay, the first year. Let's see this. Okay, this is the base year. Okay, year zero. So as I said earlier, even if you want to write the discounting factor, you still get minus 175. Okay, so the MPV for project X minus 175. Then the first year it was 100. So 100 over 1.05 to the power 1. Then the second year was 100 over 1.05 to the power 2. I think the third and fourth years, there were no values there. So we have to ignore that one. So just simplify this. The MPV here is 10.94. 10.94. Okay. So if it's 10.94, we just move to Y. Y, the initial one was minus 200. First year was 60. So 60 over the discounting factor to the power 1. Then the second year, 60 over the discounting factor to the power 2. The third year, Q. Then the fourth year to the power 4. Okay. And when we simplify this, hopefully we are getting 12.7570. This is for Y, the MPV for Y. Then we go to Z. The first one was 50. The next one was minus 100. So we discount minus 100. It's to the power 1 was the first year. Then we do it for the rest of the years. Then you simplify it. So this is the value that you are getting. So if you remember, for multiple projects, when you are using the MPV criterion, you have to compare the various MPVs. The one with the greater or the higher MPV is the project that we go for. So when the discount rate is 5%, we go for Y, because this is the answer to the Y, because it has the greatest MPV of 12.7570. I didn't do it for the 10%, but it's more likely that the decision will change when you have a different interest rate. So you do it for the case where the interest rate is 10%. We'll see what you have to do there. All right, any question? Any question? All right, let's look at the number 10, the domestic cost ratio. All right, the information below relates to the establishment of a leukemia center at the Legon Hospital. Current estimates indicate that 1,000 patients are treated in South Africa at a cost of $90,000 per patient. And then the imported equipment, machines, and then the other raw materials to cost 60 million. And when we use local raw materials, we have 100 million. Local labor, we have 5 million. Other local inputs, we have 4 million. And then interest charges on loans, we have 4 million. Then suppose the market exchange rate is 6 Ghana cedis per $1. We have to calculate the foreign exchange savings if the project is undertaken locally. So this one, we are just dealing with the project, and we are taking into consideration balance of payments issues. It's possible that we can just send these patients to South Africa, then they go and take their treatment there. That's what we call the imported output. So that's one, they've already produced the service. We are just going to buy the service, or we can import the raw materials. Then we'll come and produce the output in Ghana, and it's going to cost us 60 million. Or we can choose to use our local staffs to do the project. Okay. So we are the whole rationale is to calculate the domestic ratio, cost ratio that is saved. So the first thing you have to do, even if they don't ask you, but here they are asking us to calculate the foreign exchange savings if the project is undertaken locally. So it's just a difference between the price of the output when we buy it from the outside world, and then if we buy the equipments and then we come and produce them locally. So we just subtract the price of imported raw materials from the total cost of price if we rather import the output. Sorry. Here, importing the output means that sending the patients to South Africa to go and get their treatment there. So let's look at the eye. For the eye, first you need to find the total cost of imported output. It's not the 90,000. It's 90,000 per patient, and the patients are 1,000. So if you want the total cost of the imported output, it's going to be 90,000 times 1,000, and that will be $90 million. Okay, so if we send the patients to get their treatment in South Africa, we incur a price or a cost of $90 million. Now let's put this one here. And then the cost of imported equipment is 60 million. Now, at times in this question, they don't have that one. At times they add contingency. Okay, they'll give a percentage. So if you see that the contingency for importing the equipment is say 10%, then after getting the total cost of importing the equipment, you find 10% of that cost and you add it to the imported cost. I hope you guys understand me. At times they'll add contingency costs. Okay, so if you have contingency for the import, then apart from getting the total cost for the imported equipment, you find, if it's 10%, if the contingency is 10%, you find 10% of the cost here, 60,000. So it would have been 10% of 60,000 is going to be what, 6,000, right? So you add the 6,000 to the 60,000, then the total cost of imported equipment will be 66 million. Hey, the thing is 60 million, so 10% would have been 6 million. So it would have been 66 million. But here we don't have it. I'm telling you because it's possible that at times they bring that. So you have to do what I'm saying. Find the percentage of it and then you add it. Okay. But here we don't have that. So it's just the 60 million. So if you want to find a foreign exchange saved, you subtract the cost of imported equipment from the cost of imported output. Okay, if we bring the equipment here and we do it here, we are incurring a cost of 60,000. If we go and do it there, of 60 million, if we go and do it there, we are incurring a cost of 90 million. So we have to subtract it. If you subtract 60 million from 90 million, we are saving a foreign exchange of 30 million. Okay, we are saving a foreign exchange of 30 million. I hope that's fine. So there's the answer to the first one. This question is not difficult at all. At times it just takes only one page. Okay, but you just need to know what you are looking for. So this is for the II. I think the second one were to find the domestic ratio cost or domestic cost ratio. Okay, Now, that one is when we are producing the thing locally, we are using our local raw materials, our local labor. You add the cost of all that. So if remember, we're giving a cost of local raw materials, labor, loans, and then there was this other thing, and they were all in millions. So you add all of them. Okay. When you add them, we are getting what 113 million. Let's check there. We had local raw materials, labor, and then the fixed cost, and then other local inputs, and then the interest rates and charges. Okay. So we've been able to find the first one, the foreign exchange savings. Now we have to determine the domestic cost ratio. Okay, that one you first find the total cost of doing the thing locally with our local raw materials. So that is what we are doing here. Okay, so you just add the cost of all the stuffs that we will use locally. Now, if you want to find the domestic cost ratio, you divide this thing here is in cities. Okay, our local cost is quoted in cities, but then the foreign one is quoted in dollars. So if you want to find the ratio that they are talking about, you divide what we have in cities here, the cost of using our own staff to do it, divided by the foreign exchange savings. Okay, divided by the foreign exchange savings. So if you do this, you get an answer in the form of the exchange rate. So if you divide 130 million by 30 million, we are getting 3.766 per dollar. Okay, 3.766 per dollar. So this is the domestic cost ratio that they are looking for. So first, you need the savings, the foreign exchange savings. Then you find the total cost of doing the thing domestically. Then you divide this by the foreign exchange savings. Okay, when you do that, this is what you get. The answer will always be like the market exchange rate. So something cedis per dollar. Okay, so when you are done, whether you do the thing here or not, you have to compare it to the market exchange rate. Okay, now this is the decision rule. The project, we go for the project, we say that the project will be profitable if the market exchange rate is greater than the one that you will get. Here we had 6 cedis to $1. That's the market one, but we are getting something which is lower than 6. So yes, the project is going to be profitable. So we go in for the project. So all that you have to do is first find the foreign exchange savings. You find the total cost of doing the thing locally with our local